In this video, I will show you a geometric representation of the complex numbers. You all know the real number line, where the real numbers are sorted from left to right, from negative to positive. In order to represent the complex numbers, we extend this representation. We go from one dimension, from the one-dimensional line to the two-dimensional plane. Here we have two axes. The real axis is the x-axis and the imaginary axis is the y-axis. So here you can see the real numbers 1, 2, minus 1, minus 2, and the complex numbers I, 2i, minus 2i. And this is minus 2 plus I, because the real part is minus 2 and the complex part is 1. This number is 1 minus 2i, the real part is 1, the complex part is minus 2. Here you can see that there cannot be a concept of ordering on the complex numbers. The real numbers can be ordered from left to right, but in the plane there is no similar ordering of the complex numbers. So we must forget about the greater than, less than, greater or equal, and so all ordering relations are not useful in the complex numbers. Now we look at the geometric interpretation of the operations. Addition can be explained with the addition of vectors. So we think of the complex numbers as vectors from the origin to the complex number point. So here we add 2 plus 2i and 3 minus I, and the addition is like vector addition. Next is conjugation. Now here we have the point z is 3 plus 2i. The conjugate is 3 minus 2i. Now stop the playback of this video and try to find out which kind of geometric transformation is it, this conjugation. Well, it is just reflection at the real axis. The next operation is the absolute value. So look at this picture and try to find out what could be the geometric interpretation of the absolute value. The absolute value of z is square root of a square plus b square. But what is it? What is the geometric meaning? Well, the absolute value of z is its distance to the origin, length of the vector from the origin to the point z. And now to multiplication, which is a little bit more complicated. We start with the I, the complex number I, and you multiply I by itself. So we get I square is minus 1. We multiply again, I to the power of 3 is I times I square is minus I. And if we multiply again with I, you obtain I to the power of 4, which is 1. So if you look at those four numbers, multiplication seems to have to do something with rotation. Here the I is always rotated by an angle of 90 degrees.